All right, welcome everyone to our Backup Recovery Office Hours session today. My name is Tim Chen, the Director of Product Management at Oracle, and today we'll be talking about reducing cyber risk with zero data loss protection. And I have my team as well here, Marco Calmasini and Kelly Smith. And if you have any questions during this session, please use the Q&A. Feel free to ask any questions or any elaboration on the topics as we go through, and hopefully this will be an informative session for you. So first, our safe harbor statement, as usual. Just a moment to read. So we have some interesting topics to cover today with cybersecurity. First of all, let's just talk about why cybersecurity matters and why is that such a big deal today in today's IT economy, and also within your internal company assets as well. We'll also then talk about key cybersecurity tenets, what those are, and we'll also talk about how the Oracle's backup recovery solution, in this case, Recovery Appliance, can help you protect against database and backups from these attacks. And then we'll wrap up with some additional pointers and call to action to learn more. So, the headlines today, you really can't miss it. Cyber attacks and cybersecurity is a big topic. It's been this way for several years now. And what we're seeing is that these attacks are really becoming kind of the next generation of business outages. So, traditional sense where you have mitigations against hardware failures or disasters, the threat of cyber attacks is much more difficult, if you will, to mitigate. There are various ways these attacks can happen, much more sophistication involved, okay, in these types of threats. And so in many cases, they pose the largest security threat to paralyze an organization. Much like any kind of big disaster, any kind of outage at a company, there are consequences, both financial and legal consequences to customer data, to customer access to the data, your internal kind of organizations being affected by loss of access to that data, right? And of course, if that news makes the public sphere, this can affect your reputation, right? So this is now paramount on top of all customers' lists. Our product management group speaks to customers on a regular basis on these topics, and certainly on their mind as well. There's just a couple of things to highlight. We've seen news here. These are all public kind of news presses. UCSF in the last several months have had medical data servers encrypted, especially in this kind of global health situation that we're in. That's not something you want to hear. And was repeated that they paid a ransom to actually unlock and to retrieve that data. We also see that financial services are a prime candidate for cyber attacks. I mean, obviously, financial services hold kind of, a big lifeline in our economy. And so any kind of attack or any compromise obviously has much more impact, and companies are maybe more willing to pay the attackers to get the data back, right? So we have seen various cases, TravelX, where multi-million-dollar ransom was paid because of systems being offline due to ransomware. Capital One, Wawa Card, these are all breaches that happened where customer details were exposed online. And we just saw a recent IMF report where the impact to financial institutions due to cyber attacks was assessed to be over $100 billion, which is, not a small amount, right? This is how prevalent and how impacting these threats can be specifically. In response to these cases, various regulatory policies and government controls have come into place, specifically against cybersecurity. And just to mention these, because it's not just customer reputation at stake, but it's really the government has a stake as well, and the authorities, because of the economy, right, that we all operate in, and of the attacks that could even happen in the public sector, right, which is yet another place for attacks to really focus on. So in the U.S., we've seen examples such as Federal Reserve matter requiring attention, notes being sent out to leading financial services institutions, which is to notify institutions that there are certain areas or certain kind of discoveries, if you will, where in their systems need to be evaluated and need attention for cybersecurity. We've also seen regulations from the other government bodies, such as the FFIEC and the SEC, for tighter controls, retention, and protection against cyber attacks. We also see the government National Institute of Standards framework for improving infrastructure cybersecurity. So you can take a look at these links later, and you can request this this presentation. But it's definitely happening, and we're seeing this across the board. Internationally, same thing. Regulations have come about. Many of you are probably familiar with GDPR, which is specifically for EU citizen data protection. And we can see that there are actual fines now to move companies to institute these requirements, right? Encryption of personal data, being able to keep such data available and retained until that data is destroyed, okay? And also need to be able to access and get that data in a timely manner in the event of any kind of incident. So we do definitely see fines being paid out. You know, there's one from Marriott that I highlighted here, 100 million euro, you know, fine for cyber breach a few years ago here of guest records, right? So it's a very serious matter, and so Oracle obviously as a sort of a big part in the IT infrastructure, and hopefully while you're attending this call, can offer solutions and sort of mitigations, if you will, against these threats. Okay. And we see other fines here that have played out across various countries. UK, you can see, is kind of the highest now, with over 315 million euros at just three separate fines that have been made. So let's talk generally about cybersecurity tenants, and then just talk about the Oracle solution stack, specifically Recovery Appliance. So the standard industry model that companies and our vendors, you know, and ourselves, you know, kind of go to, it's called the CI triad, right? This is a very familiar model across the board, meaning confidentiality, integrity, and availability. Now, the step isn't about just focusing on these tenants as is. It's focusing on these tenants with a focus on cybersecurity, and not just for your production data, but also for the backup data. And why is that? You know, attackers who have to go after data in a production sense have to go after multiple servers, multiple places across, you know, different regions, across different network zones. So the work, if you will, to attack the production data could be manifold. You know, it could take, you know, quite a long time to find specific servers. Whereas your backup data could be more centralized and in sort of consolidated fashion. So if the backup data can be attacked, then those cyber attackers have an easier way to retrieve the data and to do something with it. Right? So that's what we're seeing, is not just production data, which is everyone should be concerned about and protecting, but also how easy or hard it is for attackers to get to the backup data, to unpack it, to see what it is, and to do something useful with it on their side, right? So just keep that in mind as we go through. So confidentiality, right? This applies in a few ways here. You want to ensure that your production and backup data are encrypted, right? Obviously, encryption is the sort of the mainstay of any kind of security process, but also you want to have strong access control, right, to that data. And beyond that, just the sort of general statement about access control, and you need to really think about application-aware um, encryption and control, right? And that is because applications use systems in various ways. And so when you talk about protecting data, you also want to talk about how protection of that data, securing that data, doesn't affect your production, performance, resources, and user access to that data, right? So those things have to be really thought about and kept in balance as you evaluate and look at, assess the risk if you're in your current environment. It's also important to enforce separation of duty among the various IT roles. And as you can see, just listing typical roles, the application developer, your database administrator, systems admin, and then your storage admin, meaning that each of these roles do not have ability to modify data owned by the other role, right? These roles should all have controls, lined up, and also data that's logically separated from each other, right? So there's there are mechanisms to be able to encrypt and to allow only viewing by a certain group. Those kinds of controls should be instituted as well. And also, very important is that the production and backup data cannot both be modified or deleted by the same IT role, right? That would defeat the purpose of having a separation of duty, especially with production and backup data, like I mentioned before. Both of these are critical, and in a lot of cases, even backup data is your last resort, and that really cannot be compromised or attacked. Let's move on to integrity, which is about ensuring that the data that is backed up, that is protected, can actually be recovered, right? It has application level recoverability. And so I want to make this note because just because you have a copy of the data somewhere doesn't mean necessarily that the application can actually do something useful with it, right? There's a lot of intelligence, right, in your software side the applications use, and there's an assumption of how the data should look like and how it can be restored and recovered. And especially for databases, this is an important concept to keep in note, right? Databases aren't just a bunch of files that are just sitting on a storage box, but there's a very specific, application function using those files, and they have to be restored and recovered in a very specific manner in order to be opened and then read, right? So this key part in the second bullet, we just want to highlight that storage-based only kind of mechanisms for validation and keeping files with integrity does not necessarily mean that your application level recoverability is taken care of. What that requires is application level intelligence, right? You need to have something at the app level that can give you the foresight and ability to know that data is recoverable, that data is pristine and has been validated. And you want to do this as well, again, with minimal impact to the running of the application of the production systems. You want to prevent the backup data to be modified or deleted when needed, so that the idea is, you have a pristine data, which is what we call our vault copy, if you will, which is a separate copy for your production and DR. And in this vault copy, you should have mechanisms to be able to say, I want this data to never be written or modified at all. And we do that through read-only media, right? So, in a lot of auditing and government kind of authority cases, they need proof that your backup data, even when it's not under attack, but just as a regular kind of review of records, needs to ensure that no access or nothing has been modified on that backup data. And then, of course, with that is that auditing, right? Is that activities of both production and backup system, user access, changes done have to be really, very closely audited, right? That's your final kind of record of truth, and allows you to kind of unwind back to when maybe bad changes happened from an attack or some other bad issue that occurred. And then lastly, just covering availability, right? Availability means that your production and backup systems are impervious to attacks. That if you do suffer an attack, that your data is not compromised for access. And the attacks can happen by human or non-human means. One of the other kind of corollaries to this is limiting the attack surface so that you can kind of reduce the amount of opportunities for an attack to happen. For example, number of components in your production or backup system, number of connections between the production and the backup systems themselves. If a problem happens on your production system and data has been maligned, you do not want that maligned data to flow into your backup, right? And to go unnoticed. That would be kind of a compromise on both sides. So again, going back to integrity, there needs to be a way to make sure that application level integrity is retained and that data is not just copied kind of blindly, but that the data is actually being validated and can be used for recovery purposes in that application. We also want to make sure that operational processes are automated to the extent possible and locked down. This reduces the need for any kind of access for human intervention, right? That should be kept to a minimum. That by itself reduces the ability for non-authorized or malicious users to come in and do harm. The final point here is about, in the case you have to recover the data, and say your data is held at ransom now, and you have your backup, that backup should be reliably recovered to any point in time or completely without any data loss if desired. So, with a typical backup, you may not have the most recent copy of the data available. So you might actually lose data in the process of trying to recover what you can. That's the worst case. I mean, that's the case no one wants to be in, because that has impact on your internal and your business operations. So a solution ideally for availability would allow you to restore and recover that data without any data loss to separate machines, that the original machine is compromised, but you don't in fact need that original machine anymore, because all the data is kept intact up until the moment that the attack happened, and thus you don't pay the attackers, right, the ransomware. You have separate boxes that can be used, and they're locked out of any kind of access of the original boxes that were compromised. So why Oracle databases, right? Or why are they so so important and the key part of our discussion here? Databases run the lifeblood of most businesses today, right? Oracle is a prominent figure in this. Obviously, we like to think about it as Oracle databases hold kind of the crown jewels of your business, and so these databases are geared, right, and why they're important for handling OLTP data warehouse workloads at scale, for providing security at the data level, right at the block level in the data, called transparent data encryption, and all the high availability features offered within the Oracle database itself, such as data guard and also backup recovery solution through the RMAN utility. Right? I just want to mention that the database itself has built-in capabilities, right, to handle mission-critical business data. There's also an engineered system that is built specifically to run Oracle databases, optimally, right? And that's in our engineered system we call Oracle Exadata. In the backup recovery area, our team also developed the Zero Data Loss Recovery Appliance, which leverages that Exadata framework. That's for performance of running database workloads. In this case, it's backup and restore processing, and resiliency within the Exadata system itself for a first-in-industry system designed for Oracle database protection. So it's quite unique in our market, specifically for Oracle database protection. And this system has a number of interesting capabilities, differentiators, if you will, that also work very well to satisfy the CIA triad that we saw previously. So we'll go ahead and move forward then and discuss kind of the solution. So Recovery Appliance was our engineered system that I mentioned for Oracle Database Enterprise Protection. Sort of key technologies in our system is recovery assurance, which is the ability to capture all changes that happen on the database, to be able to validate all that data as database recoverable, at what we call application level validation checks, and not just ensuring that that a data was copied and checkboxed off, but that the data is consistent, that all the files are needed, that everything is needed for an actual database restore and recovery, and knowing that, right, with a status. And also providing what we call fast virtual full recovery, which we'll discuss how that is in the next slide. The other key technology pillar is what we call backup savings, right? This is always on top of mind for any kind of enterprise backup solution. You want to avoid backing up redundant data. You want to avoid, doing more work on the production server than needed. And so the system is geared for efficient incremental forever, which means that change data is all that the system needs to provide full recovery from any point in time. The system also offloads the backup processing from production servers, and thus allows that production resources to do more, valuable work, such as your normal workloads of the day, end of quarter kind of closing, any kind of process that needs production resources. That backup, if you will, that happens every day or happens, several times in the day, is out of that daily operational window. And then finally, cloud scale. What we mean here is that this system can start with a small kind of set of databases for protection. And as you increase your estate, as you add more databases for protection, it grows incrementally. You can expand storage to multi-terabytes, even into petabytes as needed. And the system is still treated as a single backup system, right? You don't have clients or databases that need to be reconfigured to back up to, different recovery appliances. You can scale with a single system as you want. This also means, from a cloud perspective, that you have the ability to be able to offload and archive backups to a cloud storage tier in our Oracle cloud infrastructure. So you have backups that are kept for a short period of time on premise, and you want to have longer term retention for compliance or other type of reasons, those can be copied off to our cloud tier in a very seamless and integrated fashion through the recovery appliance policies. And then also for database migration, this has been a kind of a big capability. As a backup restore dedicated system, it allows high scale restore for the purposes of migrating databases from legacy platforms into, say, more modern platforms, into Exadata, into Linux, etc. Because the system can do this and offload that from the production side, it factors in very well also for migration activities across platforms. So at a high level, the architecture of the recovery appliance is that it services, right, any number of your Oracle databases running on any supported platform, any supported Oracle database version, as you see here to date. And the system works by accepting real-time data changes. So there's kind of two components to this. One is the real-time work that's going on, which is our Oracle redo logs. So the redo is shipped directly to the recovery appliance. Those that are familiar with DataGuard, it's the same technology used by DataGuard to keep a standby database synced up with the primary. So we have essentially all the changes up to the moment, right, as the production it happens. The second component of this is your backups, and that is, as I said, incremental forever. So those incremental forever backups are key because they actually perform the basis or serve as the basis for restores. So in this kind of chart you'll see here, I'm just showing kind of the progression of our incremental backup strategy. So on the first day you take a full just to see the backups, and from that point on you have a incremental that's taken every day. So every day an incremental is taken, and you have a new what we call a virtual full backup created on our system. So that virtual full is a legitimate, valid, level 0 full backup that can be used by our man for any restore operations. The caveat is that it's actually not a physical full backup. And this is great because it's efficient, right? We don't keep a full backup on the storage. We only keep the changes. But in the recovery appliance catalog, which is used by RMN, right? Your client databases, it will see that there's a new virtual full backup there, and we create metadata essentially that point to, if you will, the needed data blocks to retrieve that virtual full backup. So it's very efficient. Every day you create the incremental, every day you get a new virtual full. So in this way, you get the best of both worlds. You get incremental forever, so highly efficient, and you also get fast restores because that virtual full can be used for restore as is, and you don't need to actually merge or apply those incremental blocks in a traditional recovery mechanism. As I mentioned, the cloud storage is available to tear off those virtual full backups, the incremental backups as needed, or your archive logs, in fact. So you can have a separate copy that's recoverable from the cloud. It can be reused and restored to any location from there, both in cloud and on-premise. And we also have our DR appliance. This is essentially another recovery appliance which accepts all these incremental forever changes and the redo changes, as I mentioned, and we'll create the virtual fulls as normal. We'll validate those fulls. Everything is done on that DR or replica system. From that point on, you have the option to say archive longer-term copies to tape or to some other warm device if needed. We have integration with tape through our secure backup software that's available as well. From the point the backup is taken to the moment the backup lands on our system, to the moment it is the virtual fulls created or tiered off to cloud or to tape or replicated, you get what we call Oracle recovery validation every touch point. So all the blocks coming in and going out are verified that can be restored and recovered as a Oracle database. So quite a departure from storage mechanisms today, which don't have application awareness. The Oracle Recovery Appliance has this awareness built in and institutes this or enforces this on every touch point of the data as it moves to the system. And then we have real-time protection status and monitoring, both on space and on access to the system, changes done to the system through our special Enterprise Manager console for Recovery Appliance. So taking that architecture overview and then now putting this in a template for cybersecurity, kind of see how these capabilities really satisfy the CIA triad. You can see that we have on the left side, backing up, we have mechanisms to do encryption of the data, both at the source with TDE, in transit using HTTPS, and on the connections that RMAN clients make to the system to SQLnet encryption. So all these mechanisms institute these encryption of the data right from the beginning before it even lands on the recovery appliance itself. And of course, the validation that I mentioned end-to-end, the retention policy that's managed by the appliance does not require user intervention to do manual deletions or checking if backups are obsolete to run in that way. Also, independent separation of duties so that you have users who are can access the production data but cannot access the recovery appliance or any other system from that point on, such as tape or this recovery appliance in the vault. And then the resilient platform, which is the point I mentioned about Exadata being our platform for running Oracle database loads, both in a resilient and secure fashion. The recovery appliance inherits those capabilities themselves as well. So in a cybersecurity architecture, I mentioned some of the capabilities that kind of fall out from our inherent features today, but the recovery appliance can function now in a cyber vault place, if you will. So apart from a DR kind of system, you have the opportunity now to have a recovery appliance in your vault or as a pristine data state for cybersecurity purposes themselves. So customers that we speak to have these vaults essentially both protected from a network access. They have special fire rooms, even kind of physically or to protect people from accessing, say, the same building, but only have certain rooms that are accessible, right, to certain users. So this special vault, if you will, has this pristine data, and it figures very well into how our recovery appliance replication works today. And then we have on the right side, going down, we have our offsite tape, read-only once, right, worm media that that can be used, right? So you have a pristine copy that can't be affected apart from the actual recovery appliance that's accepting data, creating the virtual folds, etc. process. So as we go through the next set of slides, just kind of focus on each of these capabilities and how the recovery appliance relates to this through the CIA triad. The first thing we'll look at is confidentiality, right? And so in this case, we're looking at the encryption at the source, and we're also looking at retention to make sure that the data is not, deleted by any human means before its policy is set to, and also separation of duty. So going back to the CIA triad with confidentiality, you want to ensure that your production and backup data are encrypted end-to-end with strong key management policies. And so for this, I mentioned we use TDE. We recommend using TDE at the production data. TDE production data can be backed up and to the recovery appliance in the same way with incremental forever strategy with the real-time redo. All the various efficiency capabilities remain intact with TDE data, and that's FIPS compliant as well, right, with TDE. The Oracle database security also provides integration with industry key stores. So, Key Vault from Oracle is one example. Other, sort of industry key store products are available for use with Oracle, but essentially the Oracle database key and how that's managed, obviously, it should be a big part of your plans, right, for this kind of security and protection. The recovery appliance only offers two ways to get into the system from a data traffic perspective, and that is the SQLnet for the RMAN connections, that is for catalog data, finding which backups are needed for restore, querying the history of backups, looking at the backup records, right, for auditing purposes. So that's the SQLnet connection for RMAN catalog connections to the appliance. And the second one is the HTTPS connection for in-transit encryption. So that's allowing you to further encrypt everything on the wire. Then it's decrypted before it's then processed by the recovery appliance. For application-aware encryption, this point is handled by TDE. TDE is specific for the database. It has minimal performance impact to your database itself. Exadata actually has specific optimizations at the storage cell level to be able to improve further read-write performance on TDE data. So again, application awareness of the data is key to providing the best security with the least amount of impact, right, to your production data access. Enforcement of duty among the IT roles is also important. You can see here in these points that recovery appliance has a specific role for its administrator. It is not shared by the DBA. It is also not shared by any other user who needs to do reporting or any kind of monitoring of the system. Those three different roles can be separated and will not, do not cross, right? We also have the role for the tape or storage admin, which is separate from these roles as well. So one common kind of example is today with the DBA backing up just traditionally to disk, they have ability to also delete backups, right? RMAN provides a wealth of functionality and capabilities, but they can just execute a delete backup command in RMAN, and that backup is now gone, right, from disk. With the case of recovery appliance, the recovery appliance actually can set up a policy, or the admin can set up a policy, so that the backups will actually be intercepted on any delete operations, so that you don't have the ability to modify or delete those backups, right? So the policy only allows the recovery appliance retention policy to obsolete data when it's been expired on the system, but not any end user can go in and log in and delete data, as with RMAN, as I mentioned before. Similarly, the RA Recovery Appliance Administrator cannot modify or delete production database data, right? So they only have access to the recovery appliance. They can see reports of the backups of the databases they belong to. But they cannot actually look into the data itself to restore the data or to open the data for any kind of means. And right, the last point here is just about old backup data is only deleted per the retention policy authorized by the Recovery Appliance Administrator role. Next point here is on integrity under our cybersecurity tenets, and this has to do with the validity of the data to make sure that it is recoverable, to make sure that the data has not been accessed or maligned. That's through auditing and monitoring, and also that we have read-only media that at the hardware level prevents any kind of intrusions, any kind of chance where backup data can be impacted. So under these kind of category, we have a number of points, as I mentioned before, ensuring that production and backup data are validated for correctness and recoverability is paramount, right? And that can only be done through application level intelligence. And so in the database case, you need to have something running on that data and verifying that the backup data on a continual basis can be recovered. The recovery appliance was designed with this principle in mind, that it runs validation processes used by RMAN today when it does its actual restore operations, and it does this apart from the production database. So no production database or RMAN resources are needed to actually verify the data. So the data on the recovery appliance, as it's replicated to the vault, as it's copied off to the cloud, or if it's copied off to our tape devices, at every touch point, that data is validated to make sure that nothing is missing, nothing has been maligned or corrupted in between, and you get status when something is actually found that doesn't match up, that is at the Oracle block level, that doesn't match to what is expected for consistent recovery. You, the RA administrator, will get an immediate incident and then can follow that up with the DBA or the teams to ensure that things are then locked down. If it's an actual cyber attack, that you can close off network connections, that you can stop all ingest activities or replication activities, so that the data on the recovery appliance is held pristine. Enterprise Manager offers very in-depth real-time monitoring and reporting of database recoverability, and so you'll have very quick understanding and awareness when you have a backup that is missing or that's been maligned. You'll immediately see that databases become irrecoverable, or they cannot be recovered to a point in time that they were able to before, right? So these metrics and alerts you can set up allow you to discover these things very quickly, as opposed to, in a lot of cases, when you need to restore the data in the event of an attack, you then notice that the data has been compromised, that the backup data is not available, it's not consistent, it's corrupted. That's the last time that you want to be able to deal with that. It's not ideal. So knowing this up front and being proactive about it obviously is the best measure. The recovery appliance natively offloads data to tapeworm and also to cloud if needed, and so this is allowing data to be kept on read-only media. That's really the only way to make sure data isn't modified or kept, what we call it immutable, is to keep it on media that is can't be overwritten, right? And to make sure that user access to that media is also guarded and logically separated from other roles. We also rely on Oracle Audit Vault to track production database access and change activities, very in-depth product, if you will, for the database side that allows you to track these user changes and activities. On the recovery appliance side, out of the box, it provides quite intensive auditing as well for access to the system, for any users that are changing, say, policies on the system, changing retention, um, uh, you know, decommissioning databases, and decommissioning backups of the databases, for example, when they're retired. So all these kinds of activities that touch the actual recovery appliance system are monitored in real time, and immediately you can get a report on what has happened as well, to look at patterns to see if anything needs to be investigated further. And then our last point here is on availability, and that is the system itself is resilient to attacks. Data can be restored and recovered in any incident, and completely recovered, right? Not just let yesterday's backup, but everything up to the moment that the attack happened can be recovered. And so we do this through hardened, resilient architecture that Exadata already provides. The system is specifically designed for database workloads, and we chose the Exadata platform as the foundation, if you will, for our hardware and our storage mechanisms. So this includes hardened password policies, OS and DB user auditing, firewall support, integrated lights out management, everything that you have seen from the Exadata security side, Recovery Appliance can take advantage of, and kind of give you that first level resiliency right out of the box. As I mentioned, that the network access protocols to the Recovery Appliance are limited to SQLNet and HTTPS. There's no network attached storage or any kind of NFS file access, and those kinds of mechanisms are typical for traditional storage devices. This is strictly a RMAN native, if you will, integrated solution, and the traffic is only possible through our Recovery Appliance backup module, which integrates directly with RMAN for those backup and restore traffic. You can also institute VLAN tagging, which is another mechanism to isolate database zones that are being backed up. So this allows backup restore traffic to be on non-routable network zones, so you can kind of even be more flexible and allow certain databases to only have access to different zones, and different zones only have restore access from the Recovery Appliance, right? You have full flexibility to establish VLAN network zones across your client databases. With the Recovery Appliance, as an appliance, we simplify the patching and maintenance of the system so that we do kind of as few processes as needed to do patching, for example. Our patching process incorporates all compute, storage, and networking components, as well as the Recovery Appliance software itself. And so this reduces the need to have to do kind of your own kind of point patching, if you will, as you might do with a database today. But our appliance patching is covered in one kind of process and one operation that you run. And so by inherently reducing the touch points for human intervention and potential for introducing some change or other alignments into the process. And then our third kind of bullet to end this topic is recovering the data without data loss, right? You can have all the data captured in real time by the Recovery Appliance, and when an attack happens, immediately shut down the network to our system. All the data received up to the point will be converted into archive logs, and you can then have these backups restored to separate machines, separate network zones, basically in a pristine condition without any data loss. Right? So any systems today, managed by storage-backed bases, can give you protection of all the data being copied, but then the validation of that data to make sure it's consistent and to ensure that proactively that everything is there and usable cannot be provided, right, by storage products. Right? That's just not inherently available to storage products. With the Recovery Appliance, we've actually melded the Oracle Database Intelligence and specifically for restore and recovery validation into a engineered system box for storage purposes, right, and performance and scalability. So it's trying to bring together the best of both worlds for database protection. So as a summary, I just want to cover these highlights here. Cyber protection is a rapidly growing conversation. If you've not heard about it yet, you will hear about it. It hits both business and government sectors. It's kind of across the board. The Oracle databases really serve mission-critical business functions. I mean, that's kind of the mainstay of our customer base, right? Is that data is critical. There are features and capabilities of the database needed by enterprises for that mission-critical activities, and so protection and recovery of that data in the event of attacks is extremely vital, right? And to do that without losing production or backup data is the goal. With the Recovery Appliance, we provide that, right? And it also offers the most efficient backup technology, right, through incremental forever and the real-time redo shipping capabilities that we have. It inherits resiliency through the Oracle Exadata stack that it's built on. The validation done again at all touch points kind of brings together the solution, and it gives you kind of the confidence, and also for your auditing teams, the ability to say, here's our backups, here's their status, here's their recoverability, also a history of all the kind of activities that happened on the backups themselves is much more in-depth and much more tuned and specific for Oracle databases there. So this solution really does meet the CIA security tenets for cyber threats beyond what traditional backup storage can do today. So the call to action here for you, and hopefully this was informative and help you to see some new things and how to address kind of cybersecurity. Survey your mission critical databases, take stock and take a look at what you're doing today with backup recovery, and then look at your exposure to cybersecurity attacks. Look at kind of the ways that your databases can be compromised from both a data perspective and also user access perspective, and to also note what your recovery service level agreements are, right? Because at the end of the day, your business is kind of what you're supporting, and so the recovery SLAs have to match to what the business operations need for their activities and for the company as a whole. Right? Feel free to reach out to us in our Ask Tom session page. We have a feedback question section. You can ask us a question, ask for more guidance on what next steps you can take. We're happy to help, both on assessing and also providing next steps on possible solution for your enterprises. So with that, I'd like to turn it over to any other additional questions. I see one question that was answered already here, but also if you would like to, unmute yourself, you can also do that to ask a question. Yep. Just to highlight, do we see a question about XSCS customers today? Yeah. And so with XSCS databases, we have flashback, recovery manager, and object storage, right? Technologies that allow you to back up and to protect those assets. And we have a roadmap down the road to incorporate the Recovery Appliance type of functionality that I presented into the OCI environment as well. So, be on the lookout for such a service offering in the future. Okay. Not seeing any other questions here. We will post this recording to our AskTOM site. As I mentioned, you can feel free to query us, send your question, ask for assistance, any of your assessments of your backup recovery strategies, especially on the cybersecurity front, and we'll be happy to assist going forward. So thank you again for attending the session. We look forward to our next office hour session in the near future.